starting the recording. Okay, so just I will share the screen. Okay, so in the last class we seen about this strings and unpacked packed arrays. Okay, those I wrote the program, and this one I wrote in GVim. Okay, GVim editor. Mm, so that article codes, not article codes. 1 second. DV core. DV core, SV programs, data type, okay, test bench I wrote. So this one I'm going to execute in EDA playground. Just I want to show this outputs, okay, so that you can understand that concept. After that we'll go with the unpacked arrays, okay, unpacked arrays, okay. So here, what is my first program? So in this first concept, yesterday what we have seen in the first concept, after yeah, 1 second. First concept, this logic is completed, no? Struct data type, and next typedef, no? Typedef. First I told the typedef. So that program, what is this typedef inside the module, okay, typedef. So typedef is nothing but it is used to we can change one data type to another data type. That is nothing but typedef. Last class I told you, okay. So this is the program. So this is I'm converting what type of data type. That means I need to initialize the typedef inside the module. I'm converting this typedef enum to integer data type, okay. So here this I'm copying, okay. This program I explained only, okay. So first typedef inside the module, and typedef these are the list and enum data, and here I need to convert ps equal to idle. This is at index 0, so I need to convert this enum data, this idle to integer data type, okay. This I am copying, and if I see in this is my EDA playground. So here I'll paste this, okay. 1 second, 1 second, 1 second. Just I'm copying this, and I'm pasting here, okay. Just I'm running this, okay. When I run this code, okay. 1 second. Please select valid tool, okay. Valid tool, go to tool, and select the tool as Aldec Rivera, okay. Aldec Rivera, and run this program, okay. When you run this program, I am getting what I am getting, the value of PS of idle. Value of PS is what idle, and its numeric value is what 0, okay. So that means the value of PS is idle means what, so that means percentages means what, at the index what is there, so at the index that idle is there, okay. So ps dot name I gave, and this ps is integer type means it is at the which index, 0 index means idle equal to 0, okay. So this is about the typedef, and next what we have seen typedef. After that, after typedef, 1 second, 1 second. Enum data type also we have seen typedef, okay. Typedef, and next structure data type, okay. Structure data type, so structure data type, structure intent. If you see the strings, okay, if you see the strings I wrote some programs related to the strings, if you want to find out the this is structured data type, okay. This is structured data type, okay. Structured data type is nothing but where we will use this structured data type. If you want to add 2 or 3 data types in a structure, we can write in the structure. So structure packed, okay, bit, so I'm combining the bit data type, logic data type, and bit data type, okay. So this so here this program we already discussed, that packet data equal to 8 tick decimal 10, packet dot address equal to 4 tick decimal 20, and packet dot a equal to 1 tick binary 1. I want to display this packet. Okay, so here just this is related to the structured data type. So I'm copying in this EDA playground. So just 1 second. Structured data type. So IE is for editor, edit, copy, and paste in the EDA playground. Okay, so run this code. Just run this code.
Can we pause the class for 2 minutes?
Yes, okay. Okay. బ్రో 2 minutes వెయిట్ చేయమన్నది. 11 కావచ్చు. 10కే స్టార్ట్ చేసిన. 10.
Hello.
Yes. Yes.
Yeah, thank you. Thank you for
Okay.
staying.
Okay.
Yeah.
So this is structure data type. Okay, this is structure data type, and next we see in the strings, no. So strings. So we can find out the length of the string. This is length of the string. Okay. So this is the code related to the length of the string. I wrote. So system verilog is there. So this will display the message dot length, and it will find out the first character in this length. Okay, this is length of the string. Okay, just I will copy this, and just I will paste in the EDA playground. Okay, 1 second. I'll copy this length of the string. I'll copy this, and I'll paste here, and I will run this code. I'll run this code. 1 second. I'm getting an error. 1 second. If I see some other codes like string formatting or string declaration is there. Okay, string declaration. So this is string declaration. Suppose I want to declare the string. So module string declare string name initial name equal to I'm writing in term inside the inside this double quotes. Okay, 1 second. Mm, 1 second. String declaration font size 16. So I will copy this, and I will paste in this. Okay, I'll run this program. So here you got the name is Sanath. Okay, the name is Sanath. Okay, like this we can declare the string. Okay, these are some string related operations. String concatenation. So in the Verilog, we already seen the string concatenation. No? So concatenation is nothing but combining. Okay, combining. So here I wrote that is string first, last, and full. Initial begin first equal to Sanath, last equal to Kumar. So I will add full equal to what first, and space is there. No, I need to give it double quotes and last. Okay, so this is concatenating the strings. Okay, concatenation of strings. So here just I am saving in EDA playground. So concatenation of strings. This I will copy, and here I will paste. Okay, I'll run this program. I'll run this program. So here you see the full name is Sanath Kumar. Okay, so like this we can concatenate the string related operations. Okay, and string declaration over string format, string comparison. Okay, this is string comparison. Okay, so like this is simple program like here you given two strings. One is what A equal to in capital letters, that is VLSI, B equal to in small letters, that is VLSI. Initial begin, if A equal to B, display the strings matches, else that is it will display the string doesn't matches. Okay, so here just I am copying, and I am seeing in the EDA playground. Okay, run this program. So see here, string doesn't match. Why? Because both are not equal. okay, both are not equal. Suppose if I give same, same in capital letters VLSI, now if I save and if I run this program, then it will display the string will match. Okay, so if I run this program, it will display that string will match. Why? Because both are same. Okay, both are same, so it will display string matches. Okay, so these are nothing but some string related operations. Okay, and next, we already seen the casting, no? So casting are two types. One is a static casting and dynamic casting. Static casting we can run in the compile term, and dynamic casting we will run in the runtime. Okay, so that casting also I do it. This is static casting. Okay, static casting. So here if you see this program static casting, so this is so module static casting into byte. So casting is nothing but what, we can convert one data type to other data type. Okay, that is nothing but casting. Okay, so one, you can convert one data type to other data type. So I'm copying this and I am pasting this program in this EDA playground. So what I am getting, just I am running. So this will cast to byte, bit to byte. Okay, into to byte. Okay, into to byte. Okay, see here where I got here. See here, the original int is what, I given ff. Okay, a equal to what, 32 tick hff. Okay, ff means what, basically this is int. Int means what, it will take a decimal. So what is the maximum decimal value of ff? 255. Okay, 255 means what, so byte, it is converting into 2 byte means, the casted byte is -1 means, if it is a negative number, it will be represented as like a byte. In terms of byte, it will represent. That is nothing but casting. Okay, and dynamic casting also. One second, declaration string strength, structure type, type def. Typedef also I explained. Okay, this is enum casting. Okay, this is dynamic casting. Okay, enum casting. So enum casting, if you see this, I wrote dynamic casting. Okay, dynamic casting. So type, this is enum logic 1 is to 0. Idle, so I given some values. Idle equal to 2 tick 0 0, run equal to 2 tick 0 1, wait, stop, state of t. So module enum casting demo, int raw value, int current state. Okay, so raw value equal to 2. So I am giving static cast into enum cast. So I can convert into to. So by using static cast, I can convert into to enum. Okay, so enum. Okay, so here if you see, so just I am copying. This is enum. I am converting into to enum. Okay, so if I paste here and if I run this, if I run this, I will get Caston enum is what, weight. Okay, Caston. So that means Caston raw value is how much? Raw value is 2. Okay, raw value is what, weight. Where is the weight? Weight equal to 10 is there. So raw value is 2, and the casted enum is what, weight. Okay, by using casting, you are casting from int to enum. Okay, integer value to into the cast. Okay, so this is about the casting, and next we'll see the uh, packed arrays. I told you yesterday. Okay, packed arrays also I wrote. So if you see the packed arrays, I wrote three programs. Okay, packed arrays, there are three types are there: 1D array, 2D array, and 3D array. So if you see the 1D array, so I told you 1D array is same as vectors in the Verilog, no? So 1D array is same as the vectors in Verilog. Okay, so here if you see, so this is a 1D packed array. So this I explained, like module packed 1D. So I am initializing bit 7 down to 0 data. So this is 1D packed 8 bit initial begin data equal to, I am declaring the data equal to 8 tick binary 10101010, 8 bits I am declaring, and I am displaying the data. Okay, this is 1D packed array. Okay, so I am copying this and just I am pasting this. Okay, I am running this. So when I will run, what I will get, the 1D packed array is what, 1010, whatever I displayed, okay, the data will be displayed. So 1D packed array is this one, okay. So this is 1D packed array, and 2D packed array also I wrote, 2D packed array. So last class we seen the 2D packed array, 1D packed array and 3D packed array. So this is a 2D packed array. So 2D packed array means so two values you will need to give. It's like a matrix. Okay, it's like a matrix. So it consists of what, you need to come from right. Okay, so it consists of 4 rows, and in 4 rows 8 bit each. In 4 rows 8 bit each. Okay, initial begin matrix is what, in first row I am giving AA, and second row BB, and third row CC, and fourth row DD. Okay, assign the rows. Okay, after that I am using a initial the for loop for int I equal to 0, I less than 4, I plus plus. Okay, I plus plus we can use in the system Verilog, whereas in Verilog we can't use I plus plus. In the Verilog I told you in the for loop, that is I equal to what, I plus 1 we need to use. Okay, so dollar display, in order to print these values, row percentage D percentage B, okay, I and matrix of I. Okay, so this I want to execute. Okay, 2D packed array. Okay, 2D packed array. So just I am going, and I am executing this. Run in the program. Okay, see here, row 0 is what, row 0 is AA. So row 0 is what, 8 tick H AA means what, it will store matrix I. Okay, matrix I, one second, row 3 you are getting as AA. Okay, row 3 you are getting as what, AA. So 10101010. Row 2 you are getting BB. So 10111011. Row 1 you are getting CC. So 1100 1100. Row 0 you are getting this DD. DD is nothing but D in binary is what, 1101, no? So 1101 you are getting. Okay, so like that we can display the 2D array. Okay, and next 3D array. This is 3D array. So I can initialize this 3-dimensional array. So see here, this is 3-dimensional array, module packed 3D array. So I need to initialize this 3 dimensions. Okay, 3 dimensions I need to initialize, and initial begin cube equal to, so I can initialize with this like this I can initialize these values, and I need to use the two for loops. Okay, so I equal to 0, I less than 2, and I plus plus, and for j equal to 0, j less than 4, j plus plus. I need to display this cube. Okay, so this one I can see, this is 3D packed array. 3D packed array, copy, and here if you paste. Okay, if I run this program, here what you will get, see here, cube 0 of 0 equal to what, 0 of 0 equal to what you are getting, 1000. So that means this is 0 of 0. This is nothing but 0 of 0. 0 of 0 is 1000, 1000, 88 you are getting, and next 77 you are getting. Okay, 0 1, and 0 2. 0 2 is what you are getting, that is 6 6 6 you are getting. Okay, 0 3, 0 3 what you are getting, 5 5 you are getting. Okay, 5 5. Okay, again 1 0, 1 0 means what, 4 4, 4 4 you are getting. Okay, 1 1, 3 3 you are getting, 1, and 1 2 you are getting, 2 2, and 1 1 you are getting, 1 3 you are getting, 1 1. Okay, so like that this is a 3D array. Okay, so whatever the concepts we discussed, I am showing with the program. Okay, is it fine? Any doubt in this?
Yeah, it's fine.
Okay, yes, 1 second. Yeah, so today we'll discuss about unpacked array. Okay, we'll discuss about unpacked array. Okay, unpacked array in SV along with the programs. Okay, unpacked array in SV. Okay, So what are this unpacked array? So caching completed. One second. Queues. One second. Okay. So unpacked array. So in unpacked array also you have three types: 1D unpacked array, 2D unpacked array, and 3D unpacked array. Okay. So if you see the unpacked array, unpacked array. So in unpacked array you have 1D unpacked array. 1D unpacked. So 1D unpacked array. 1D unpacked array. Okay. So and next to 2D unpacked array. 2D unpacked array, and also 3D unpacked array. 3D unpacked array. Okay, first we will see the 1D unpacked array. What is this 1D unpacked array? We will see. Okay, so like so what is the syntax for this is so 1D, first we will see the 1D unpacked array. So the syntax is 1D unpacked array. So unpacked array here. So data type, array name, and size. Array name and size. Okay, data type, array name, and size. Okay, so here if you see like so suppose if you are using int data type, int array, and 1 is to 0. So this means so here how many locations you have? 0 location and 1 location you have. Okay, 0 location and 1 location you have. Suppose if you consider int array, 2 is there. Int array 2. So 2 means what? 2 means so like this second location, it is nothing but second location. Okay, so here what I can do, I can use this program. So I wrote the program by using 1D array, that I will explain you. Okay, so after explaining I will execute that program. So see here, one packed array also I wrote the program. So tb 1D array, there are three methods are there. So I will explain you with these three methods. 1D array. So method 1. Okay, so 1 second, I close this. Okay, so this is 1D unpacked method 1. So what is this method 1 means here? uh, so this is the 1D method 1. So I am initializing int array 2. Okay, declare the integer array with how many elements? 2 elements. Okay, and I need to declare one other array, that is int array 2 2 comma 2. Declare another array for aggregation. Okay, method 1 is what? I can initialize individually. Okay, so array of 0 equal to what? 1. Array of 1 equal to what? 2. Okay, so this is what method 1. Okay, and array aggregation method is there. Array aggregation method means what? With the brackets I can give like tick and I can give with flower bracket 1 comma 2. Individually I can assign the values to the array, or like I can use array aggregation using concatenation. I can use concatenation operator. In Verilog we already seen, no? So how we are using concatenation operator? That is by using curly braces we are using. So this is tick 1 comma 2. 1 comma 2. Okay, and display the content. If you want to display the content, this is method 1. You can use for loop also. Okay, for I equal to 0, I is less than 2, I plus plus begin dollar display. The value of index is percentage d is percentage d I of array of I. Okay, end module. Okay, so initial begin for loop we need to end. You started the begin, no? And this initial begin you need to end, and next this also you need to end. Okay, so this is 1D array method 1. Okay, 1D array method 1. So just this one I am copying, and just I am seeing the waveform the output in the EDA playground. Just pasting. Okay, I'm running this program. So when I run the program, one second. Okay, 3D packet 3D I copied. One second. One second. This one I need to copy. 3D. This one. This one copy. One second. I will paste and run the program. So see here, the value of index 0 is what? Index 0 is 1. Okay. Why? Because I given like array 0 equal to what? 1. Okay. The value of index 1 is what? 2. Okay. Array 1 equal to I given 2. Okay. So like this, I can get the values. The value of index 0 is 1 and the value of index 1 is 2. Okay. So this is nothing but method 1. Method 1 means how you are declaring the array and how you are displaying the array. Okay. How? So by using for loop we are displaying the array. That is nothing but method 1. Okay. And next is method 2. So what is this method 2 is I need to use for each loop. I need to use which loop by for displaying I need to use for each loop. Okay. So see here, so if I am using this for each loop, same thing. So I declared the array of 2, and array of 2 of 2 also I declared, and method 1, so individual assignment. Okay. And method 2 is nothing but you can use array aggregation using concatenation. And this is how to display this one is nothing but you can use for each loop, for each. Okay. For each array of 2 of m is nothing but begin. I need to display this value. Display the value of index is percentage d is percentage m comma array of 2 of m end and end. Okay. Method 1 means you can use for displaying, we can use for loop, and method 2 we can use for each loop. Okay. So this one I am seeing the output. So just copy this. Okay. Copy this and just paste in this. Okay. Paste in this. One second. So whatever the program is there, that I pasted, and I am running the program. Here you see, you got the value, no? The value of index is 0 is 1 and the value of index 1 is 2. Okay. So by using for each also we can display the values. Okay. This is for each loop. Okay. And next is I can use this format specifier for printing this values. I can use this format specifier, that is percentage p. Okay. For displaying this. Okay. Whole thing is same only. Int array 2 of 2 is 2. Method 1 is individual assignment. I need to assign these values, and I can use array assign aggregation or concatenation. Okay. For displaying this contents, first we use for loop, and next method we used for each loop, and next method in third method we need to use this format specifier, that is nothing but percentage p. Okay. So for I equal 5, for int of I equal to 0, I less than 2, and I plus plus begin dollar display, the value of array is what? Percentage p array of 2. Okay. I'm using a format specifier, that is nothing but array. Okay. Percentage p. Okay. So this I want to display. So copy this and just video playground. Okay. So just I am pasting in this. Okay. I am running the program. Just run the program. So I got the values. The value of array is what? So 1 comma 2. So it will be displayed. Okay. Array, the value of array is what? 1 comma 2, and the value of array is 1 comma 2. Okay. So I need to use tick this flower braces 1 comma 2. Okay. 1 comma 2. So by using this format specifier, that is percentage p, I can display the array. Okay. I can display the array. So that means in 1D unpacked array, so we can display the arrays in 3 methods. One is for loop. Okay. We can use for loop, or we can use for each loop, or we can use the format specifier, that is percentage p. Okay. Next you see. So next is what 2D array. Okay, two-dimensional array. So two-dimensional array. So how it will look like two-dimensional array. So 2D array. If you see the 2D array. So this is 2D array. Two-dimensional array. Data type. Syntax. What is the syntax for 2D array? Okay. Syntax for 2D array. Okay. Data type and array name, array underscore name. Okay. And you have rows and columns. It will be like a matrix. Okay. So this is what row. Okay, rows, and this is columns, rows and columns. Okay. So suppose example, if you take example reg array 2 3 is one day array is fine. Shall I move forward?
Yeah.
Okay. Yes. Next use. So this is what this is rows. Okay, this is rows, and this is what columns. Okay, so how it will be there, that means these are nothing but rows. So how many rows are there? You have two rows are there. Okay, two rows are there. So this is what row 0 and row 1. And how many columns are there? Three columns are there. Okay, three columns are there. So that means this is what array of 0 comma 0. Okay, this is array of row 0. So 0 comma 0 and 1, row 0 column 1. Okay, like that. This is array of 0 and 2. Okay, 0 and 2. Okay, so like this is 2D array, two-dimensional array. Okay, two-dimensional array. So for this if I wrote the program for two-dimensional array, just I will explain. So in two-dimensional also there are methods are there. Same thing, like we need to use for loop, for each loop, and this format specifier. First we will see this method 1. Okay, so this is the program for method 1, two-dimensional array. So if you see this one, module two-dimensional packed array method 1. So I'm initializing reg array of 3 equal to what, 0 to 1 and 0 to 2. Okay, 0 to 1, 0 to 2, integer I comma j. And method 1 means individually I can initialize this array. Okay, individual assignment. Okay, array 3 0 comma 0 equal to 1 tick binary 1, 0 comma 1 is 1 tick binary 1, 0 comma 2 is 1 tick binary 0, 1 0 is 1, 1 1 is 1, 1 2 is 1, and displaying using for loop. Okay, so I'm using this is this is a two-dimensional array. I need to use two variable, that is I and j. Okay, so 2 rows and 3 columns. Okay, I is for rows and j is for columns. So for I equal to 0, I less than 2, I equal to I plus 1, begin. For I j equal to 0, j less than 3, j equal to j plus 1, begin. I need to display this arrays. The value of array is what, percentage d is percentage d, I comma j comma array of 3 I comma j, I and j, end and end model. Okay, so this is the program. So this program I need to display. So how to display this program? So just copy this and just paste in the EDA playground. Okay, so when you paste, when you run this program, okay, when you run this program, what you will get, we'll see. Okay, so here, see here, the value of array of 3 0 comma 0 0 is what, 1. Okay, the value of array 0 1 is 1. So whatever I initialized, that is displaying. Okay, the value of array of 0 2 is 0, the value of array of 1 0 is 1, and 3 0 is 1. Okay, 1 2 is 1, like that it will be displayed. Okay, so this is the method 1. Okay, and next if you see the method 2, unpacked array. So this is the program for method 2. Edit select font 16. Okay, so I can use means same thing, that initialization is same only. Method 2 is nothing but aggregate assignment. Okay, method 1 is directly you assign the values. Method 2 is nothing but aggregate assignment. Array 3 equal to what, tick flower bracket and tick again flower bracket, one tick binary 1, one tick binary 1, one tick binary 0, comma, flower bracket close, again tick, one tick binary 1, one tick binary 1, one tick binary 1, and two flower brackets close. Okay, so you need to use aggregate assignment method, and I am displaying by using nested loops. That is, I is for rows and j is for columns, and this is for loops. Okay, for the for loops, and after that I am using the display statement. Okay, display statement. So this one I am executing. Okay, this is nothing but array aggregation method. Okay, so copy this, just paste in this. Okay, run this program. So if I run this program, what I will get, see here, same values I got. Array of 3, 0 0 is 1, 0 1 is 1, 0 2 is 0, 1 0 is 1, 1 1 is 1, 1 2 is 1. Okay, so this is method 2. Okay, and method 3 is there. This is method 3. Edit, select font size 16. Okay, this is method 3. I think method 3 is same only. Okay, normally for displaying this method 3, I need to use which method, means for each loop. Okay, this is the two-dimensional array using for each loop. Okay, so like so if I see this program for each loop, okay, see here, so declaration is same, module two-dimensional array by using for each loop. Okay, this for each loop is also like we can use in the tickle also for each loop. So that means two or more indexes are there, two or more indexes are there, that will be applicable for each and every index. Okay, that is nothing but we call as for each loop. Okay, so here we are declaring this rows and columns, and I'm initializing by using aggregation assignment. Okay, aggregation assignment, and I'm using for each. I can use what array 3 of I, array 3 of I begin, and for each array 3 of I comma I begin, display the values. So I need to display the values. The value of array is percentage d I comma j, array of 3 of I comma j. Okay, so this one I want to display. Just copy this and just paste this. Okay, run this. Okay, if I run this, what I will get, same thing. So that means 0 of 0 is 1, 0 1 is 1, 0 2 is 0, 1 0 is 1, 1 1 is 1, 1 2 is 1. Okay, so like this we will get. Okay, so this is about two-dimensional array. Okay, this is about the two-dimensional array. Okay, is it fine, two-dimensional array? Any doubt in this?
No doubt. I
Okay,
got it.
yeah. So next is three-dimensional array. Three-dimensional array is so how it will look like means 3D array, 3D unpacked array. So 3D unpacked array, 3D unpacked array, if it is like this, suppose reg array, reg array, let us take 2, 2 and 3. Okay, how it will look like, so one dimensional means you need to come from right side. Okay, you need to come from right side. Okay, like this, so if you take this one will be like what, rows and columns, no, how many rows and how many columns, here two rows, it consists of two rows 0 and 1, and how many columns you have, three columns you have. Okay, three columns, and it is like a three dimensional, so it's like at the end. Okay, it's look like this. Okay, at the end it will be like this. Okay, it will be like this. Okay, and at the end it will look like again, so again backside there are three are there. Okay, backside there are three are there, and here two rows are there, two rows are there, and here three are there. Okay, so this is nothing but three-dimensional array, three-dimensional array, it will look like three-dimensional array. Okay, and if you see like mm, so if you see packed and unpacked array. Okay, so packed and unpacked array means if you combine this packed and unpacked array, packed packed and unpacked array. Unpacked array. Okay, unpacked array, if you combine, what you are getting, suppose reg 1 is to 0, array of 2, array of 2. Okay, array of 2. Okay, so this is nothing but just you are creating a memory. In the ram also we already seen, no, creating a memory, we are using a vector as well as arrays. Okay, so how to create a memory, we need to use a concept called vector parallelly array. Okay, so you need to come up with two rows, two rows, you need to come from right side. Okay, two rows are there, and how many columns are there, 1 is to 0. Okay, 0 comma 1, like that. Okay, suppose if you consider like reg 1 is to 0 and 1 is to 0, array of 2, array of 2. So array, two locations are there. Okay, in this these are 2 bits, each of how many bit, 2 bit, each of 2 bit. Okay, and here if you see, so how many locations are there, total you have 2 locations, you have 2 locations, and 1 is to 0. So 1 is to 0 means what, 2 locations, each of how many bit, you need to come from right side. Okay, this is first, and in this how many location, how many like 2 locations, and in this how many values, that means it is divided into 2, again it is divided into 2. So that means this is 0 1, again it will be like what, 0 1, and again here this is 0 and this is 1, again this is 0 1. Okay, 0 and 1. So you are combining both packed array and unpacked array. Okay, suppose if you consider this one, reg 2 is to 0, 1 is to 0, array of 2 comma 2. Okay, array of 2 comma 2. So how it will look like, this is first and this is second. Okay, so basically like 2 locations are there. Okay, 2 locations are there, again so 2 locations, in this again it is divided into 2 to 2 locations, again this is, these are 2 values. Okay, 2 values, and here 2 is to 0 means it is divided into 3 locations, 3 locations, again inside there are like 2 2, inside this is there, no, inside there are 2 2. Okay, so that means we can insert the elements by using this method, no. So how to insert the elements, by using array aggregation method. Okay, we can insert the elements into the array. Okay, there are 3 methods are there. One is what, insert the element using array aggregation method. Okay, array aggregation, array aggregation method. Okay, and we can insert the element by using accessing the memory location, accessing the memory location, or we can insert by using we can display by using for loop and for each loop, for loop and for each loop, or by using format specifier. Okay, so like this. Okay, so like this we can display. Okay, so this is about unpacked array. And one second, here if you see, this already shared. One second, SV for this one you see. So here these are the introduction to the data type, we already seen, no. So these are the data types. So basically in the Verilog there are two state data types are there. Two state data types means what, 0 and 1. Unlike four state data types are present in Verilog. Okay, in SystemVerilog you have two state data type, but only 1 to 4 state data type is available, that is logic data type. Okay, so if you see, so that means this is type, either it is 2 state or 4 state, signed or unsigned, and number of bits, and it is used in SystemVerilog or Verilog. Okay, short int is 2 state data type, and this is signed data type, number of bits is 16, and this we are using SV. Okay, SystemVerilog. Int is also 2 state data type, signed data type, the number of bits is 32 bit, and SystemVerilog. Okay, long int is also 2 state data type, signed and this is 64 bit, and this you are using SV. Okay, byte also, byte is a two state data type, and a signed data type 8 bit. Okay, the number of bits are 8 bit, and this is you are using in SystemVerilog. Okay, bit is there, bit is also two state data type, and bit is a unsigned data type. Unsigned data type, number of bits are 1, and we are using in SV SystemVerilog. Logic is there. Okay, so there is a only one data type which is there in the SystemVerilog, which is 4 state data type, means logic data type. I told you, logic data, by using logic data type, we can use your variable in continuous assignment as well as procedural assignment. Okay, so that is logic as logic data type, that is 4 state data type. 4 state data type means what? This logic data type can be what? Either it can be active low or active high, or unknown or high impedance. Okay, so this is a 4 state data type and unsigned data type. Okay, and number of bits are 1. Okay, we are using in SystemVerilog. Okay, these we are using in reg is 4 state data type, unsigned data type, number of bits are 1 bit. Okay, if I consider like reg a, this is how many bit? This is 1 bit only. Okay, 1 bit only, so this is 1 bit we are using in Verilog. Integer data type, 4 state data type, signed data type, the number of bits can be greater than or equal to 32, and we are using Verilog. Real data type. Okay, and two state data type. Okay, signed data type, and 64 bit, the maximum value is 64 bit, and we are using in Verilog. Okay, short real, two state data type, signed, and 64, number of bits is 64, and we are using in SystemVerilog. Okay, real time data type, two state data type, signed, and 64, the maximum size is 64, and we are using in Verilog. Time data type also there, we already seen in the Verilog. 4 state data type, unsigned data type, so the default size is 64 bit, and we are using in Verilog. Okay, so this is the basic data types which are present in Verilog and SystemVerilog. Okay, these data types are used in SV. Okay, these data types are used in SV, SystemVerilog, and these data types are using in Verilog. These data types we are using in Verilog. Okay, so I want to tell you about the summary of this data types. Okay, summary of this data types. Okay, yes.